So today we will talk about the schematic diagram of the signal board, signal direction. I have here S9 version 4.1. So there is a 5 signal direction: RST, BORI, and CLK. We can start from here 0, 1, 2, 3, 4, 5, 6, 7, 8, okay, till 24, and then 24, 25, 26, and then from here 27, 28, 29, and 30, 31, 32, till this one it's 60, 61, and 62. So from here the signal, for signal, it's going from 0 like this. For signal, we have 4 signal. It's go from 0 and to this direction, then from here to here, from here to here, from here to here. And the signal RI, it's go from vice versa, from here to here, just RI. Let's talk about the first signal, CLK. It should indicate 0.9. This board is faulty, it's giving me 0.6. So let's talk about the CLK. CLK signal, it's go from here and it should indicate 0.9. So from the signal flow direction generated by the V1 25 crystal here, this is 25 ohm crystal oscillator, and the CI and CO. So we have CLK, we have CO, we have RI, we have BO, we have RST. So CLK, let's go from the 00 chip to 62 chip, like that. And CI and CO signal, it's enter from IO port 1. This one is the IO data chip, data cable, and then enter and then transmit from the chip number 00 to the chip 62. So when the voltage line is not inserted, the voltage is 0 integrated. The voltage are the time of the operation is 1.8. So if the voltage are not is not inserted, so it's indicate 0. And we need to talk about RI and RO signal flow direction, and the chip returns from the chip number 62. So we have RI and RO signal flow direction. It's returned from the chip number 62. Okay. So it's indicate from the chip number 62 to the chip 00, number 00 chip, and then return to the control return board from the IO port 12 pin. When the IO signal is not inserted, the voltage is the voltage at the time of 1.8 when the control return board. So, and the red, there is a signal red. The signal red, it's indicate the RST. So the red signal, the last one here, RST. It's coming from the IO port, then from 00 chip to 62 chip transfer chip transmission. So if no IO signal, this signal is indicate standby. It's 0 voltage during its standby. How to indicate the faulty chip? if we connect the data cable, so if we measure the CLK output, here it's giving me nothing because there is a faulty chip. But if remove the data cable, we need to remove the data cable to measure the voltage. So it's better to. Okay, if I connect just power supply 12 volt and I test the CLK. It's indicate 0.4. It should indicate 0.9 CLK, and the otherwise is 0. So CLK it should indicate 0.9, and the CO it should indicate 0, and now it's 0.4. And RI it should indicate 0. Sorry, RI it should indicate 1.7, and the CLK it should indicate 0.9. So this is the faulty board. So as you can see here, all signal indicate 0.4. So 0.4, RI 0.4, CO 0.4. CLK 0.4. I have here a hashboard, fixed hashboard, just to show you the difference of the voltage. If I test the chip here, CLK at 0.9, it should indicate 0.9, and the CO 0, RI it should indicate 1.7. So this board it's working fine, and the other RO it should indicate 0, and RST it should indicate 0. So if we connect just a power supply, all signal are off 0 except CLK and RI. So from here I have RST, PO, RI, CO, CLK. We can measure voltage or resistance. So during of course during maintenance, the test point between the test chip is the most straight the fault location. So if we need to know which one is faulty, we need to measure the voltage on this pin, on this signal, and we need to test the resistance. Okay, so let's talk about these things. I have here I/O, and I have here DC BIC control with the power supply 4.14 volt boost. Okay, and this heat sink, it's named one of the voltage domain. Here we have inside test point. We have capacitor. We have a capacitor, small capacitor. This one DC, and this should indicate 14 volt. I have a crystal here, oscillation 25 clock, and of course I have small power supply. Its name LDO this one, the small one. So the detection method, if we need to test the S9 hashboard, first we need to plug just power supply, this one, 12 volts. DC-DC output is around 9 volts, and the boost output voltage is around 14 volts. So test point, when we connect the power supply just, and we of course don't plug I/O line, this one, just power supply, and the test point, this is a test point, must have CLK 0.9 and RI 1.8 volt, and other test voltage is 0. Okay, now if we need to talk about the core, this one, okay, when this voltage is abnormal, generally the voltage domain of the chip core short circuited. I have found the S9 hashboard, there is a short circuit of this core. Okay, but if there is no short circuit, the LDO 1.8, when this voltage is abnormal, so the chip LDO 1.8 short or open circuit. And this is LDO, small one. It's a power supply core, name LDO. And when this voltage is abnormal, the chip LDO may be open circuit or shorted. It should indicate 1.8. Now let's talk about BIC schematic. This one, from the pin 1, it's a VDD. This pin 1, we can know the pin 1 according to the sign of here. There is a like hole. This is pin 1, and till pin 1 till 14. So 1, 2, 3, 4, 5, 6, 7. Okay, and then 8, 9, 10 till 14. The function of this BIC, of course, we need to control the heartbeat signal. Okay, so if not, with the heartbeat information, BIC will work for 1 minute and then shut down. So BIC pin 1 is VDD, okay, 3.3 volt. It should be 3.3 volt, and the pin 14 ground. So, and the pin 9 and pin 10 are connected to 12C. Here we have 12C. This 9 and 10 connected to 12C, and then to I/O port to control board, and pin 5 or 6, 7 are BIC address, and the pin 4 and is a 3 volt, and the pin 8 is BIC. Power supply Mosfet. So sometimes the Mosfet not working normally. If we need to test the Mosfet, so the red one here, and we can test the Mosfet like that. Here we have 3.0, which is good. Here we have 3.0, that's good. Here we have 1.0 and then shut down, 1.0 and shut down. It's a normal. Also here, the same. Here we have 9 volts. We talked about the 9 volts boost, and here we have 9 volts. So if we need to check for Mosfet like that, we have 9 and we have 3.0, 3.0. This power supply, it should indicate 6, and then it should indicate 1.7. So as a pin 1.7 and the pin 4, it's 9. We need to put flags. So I connect the board to data cable on the power supply, and here the program Antminer. How can we test the hashboard if it's working or not? We go to the system, and there is a new system which we can look at the chip, miner configuration, and then mining program. So I just connect one hashboard, and here we can see the chip and the temperature of the chip. Okay, so all is working good. So 00 chip is 66 temperature, and all the green light, if it's green it's good, if it's red it's not. You can see the kernel loop, and here we can see all the program related to the chip. Here we have miner fixed frequency, read the IC voltage 140 on the chain 6, A60 is 550, and then ASIC 1 till ASIC 62. So there is no error here, and then it's repeat the kernel loop.